Hello viewers, in today's class we are going to discuss yet another important conceptual and elementary problem from limits, right? So here our limit, it involves the greatest integer function, but in our later steps we'll convert it into the fractional part function, right? So this is a very important limit, and here we will learn how to evaluate such type of limits where fractional part function or the greatest integer function are involved, right? So let us start, and let us use the definition of fractional part function to evaluate this important limit, right? So now let us first call this limit as L, right? And we have to find the value of this limit L, and here we are given limit x tends to 0 plus x over a and greatest integer of b over x, right? And here the positive sign shows that we are dealing with the right hand limit, right? Okay, so now let us take the definition of fractional part function, right? So now we know that the fractional part of p is given by p minus greatest integer of p, right? So this is the definition of fractional part function, and here the domain of the fractional part function is the set of all real numbers, and the range is from 0 to 1, that is p. It lies between 0 and 1, right? So the range is given by 0 comma 1, right? So here if we take this term to this side and this term to this side, then we see that we can write the greatest integer of p as p minus a fractional part of p, right? So we have what we have done here, we have taken this term to this side and this term to this side, and now if we take p is equal to b over x, then we have b over x, the greatest integer of b over x as b over x minus the fractional part of b over x, right? So now we'll substitute this value over here. So now this limit L, it becomes limit x tends to 0 positive, and we have x over a, and for greatest integer of b over x we can write b over x minus the fractional part of b over x, right? Now we'll multiply these two terms with x over a. So now we have limit x tends to 0 positive, and we can write x over a times b over x, and here we have x over a times the fractional part of b over x, right? And this x and this x get cancelled, so we have limit x tends to 0 positive, and we have b over a minus x over a and the fractional part of b over x, right? So now at this step we'll do an important thing here. What we will do, we'll write this expression as limit x tends to 0 positive. Here we have b over a minus here we have x over a. So now what we will do, we'll multiply by b and we'll divide by b, right? So here we have b over b, right? And here we have the fractional part of b over x, right? So here b and b will get cancelled and we'll get the same result here. So what we have done here, we have multiplied the numerator by b and the denominator by b, right? So now we can write it as limit x tends to 0 positive. Here we have b over a, and now see, we can write this term as c. We can take x to the denominator of b, so we can write b over a. This is the b over a, and now we can write this term as the fractional part of b over x, and now this x over b can be written like this, that is b over x, right? So this is a simple thing here. What we have done, we have collected this b and a, so we have written b over a, then we have taken x to the denominator of b, so we have written b over x. So here we have got a sort of symmetry, that is the fractional part of b over x divided by b over x, right? So now we have already assumed that b over x is p, and see, we have p is equal to b over x, right? So here we'll substitute p is equal to b over x, where this p lies between 0 and 1, and see, when x tends to 0, that is when x tends to 0, then obviously p tends to infinity, right? Because here we'll have b over 0, so when x tends to 0, then p tends to infinity, right? So now we'll transform this limit as limit p tends to infinity, right? Because here limit x tends to 0 plus will change to limit p tends to infinity, because we are making this substitution, and here we have b over a minus b over a, and for the fractional part of b over x we can write fractional part of p, and in the denominator we have p, right? So this limit is now transformed to this limit by making this substitution, right? So viewers, here the numbers a and b are positive integers, and the range of this fractional part function is from 0 to 1. So sorry, here we'll have the fractional part of p, so the range is from 0 to 1, and here the numbers a and b are positive integers, right? And moreover, here see, we are given x tends to 0 positive, right? So it means x approaches to 0 from the right of 0, right? So x approaches towards 0 from the right hand side of 0, and here we are assuming that p is equal to b over x, so x is always positive and b is always positive, because here we are given that the numbers a and b are positive integers, right? So b is positive, it is given as positive, and x approaches from the right of 0, so x is positive, hence p is also positive, right? So we can write p greater than 0, right? So now here we'll again make use of the definition of fractional part function, and see, this fractional part of p, it lies between 0 and 1, right? So the domain, the range of the fractional part function is from 0 to 1. Here we have the closed interval, here we have the open interval, and now if we divide throughout by p, because we wish to get the fractional part of p over p, so dividing throughout by p, so we have 0 over p, and here we have the fractional part of p over p, and here we have 1 over p, right? And obviously p is greater than 0, right? So now this is 0 over p, so this is 0, and here we have the fractional part of p over p, and here we have 1 over p, right? So now if we take the limit, that is limit p tends to infinity, then we see that 1 over p, right? That is, when we take the limit p tends to infinity, then the limit p tends to infinity 1 over p is obviously equal to 0, because 1 over p will go to 0 whenever p tends to infinity, right? So here we observe that the limit p tends to infinity, that is the fractional part of p over p is equal to 0, right? Because here we have 0 and the limit p tends to infinity 1 over p is also 0. So the limit of fractional part of p over p when p tends to infinity is 0, right? So now here we have b over a, and then we have minus b over a, limit p tends to infinity and fractional part of p over p, and we have b over a minus b over a, and this limit is now equal to 0, right? So now this term is 0, so we have b over a minus 0, so this is b over a, right? So viewers, the value of this limit is equal to b over a.